All right. So in the previous video, we have gone through as far as computing our descriptive statistics, specifically the mean, the SD, the percentile, and the crude histogram using the skimmer library, specifically the skim function. And this is basically the syntax that we use to do that. And prior to that, in earlier videos, we were able to discuss about setting the working directory, opening the libraries that you need, reading in the data set, using both the point and click and the syntax, and creating an object or a new data frame which contains only the variables of interest that you have from an even larger data frame. So in this part, we're entering another step in the process, which is creating your histograms. Now we know that when we are dealing with continuous data, one of the ways through which we can visualize uh, how the data is distributed or how the scores are distributed is by creating a histogram. And in R, one of the ways through which we can do that is to use the ggplot2 package, which also comes in as a package when you call tidyverse. So when you call tidyverse using the library function, it automatically calls in the ggplot package. I personally love this package, just like what I mentioned earlier, because it allows us to create colorful and beautiful images. Now, the ggplot2 package uh, doesn't only create histogram, it also creates line graphs, bar graphs, scatter plots, and it can be used to create several iterations of specific plots that you might need. But for this video, I'm only going to focus on creating the histogram, which is basically the first ggplot uh, figure that I was able to create. Now, remember that the data frame that or the object that we have created is called chap4, right? So we will be using the name of the object in creating the ggplot, as well as the labels that we named our variables with. The ggplot function from the ggplot2 package uh, follows a certain if you would call it, it's a certain syntax or a certain pattern. Right? So the first part is the function name, then open parenthesis, then this is the data frame that you are using, followed by a comma. Then the AES function or argument is basically uh, telling you about the aesthetic uh, arguments that you want to use. So this will help us out uh, tell our how we want the histogram to look like. What are the variables that have to be used in creating the histogram? So for this particular task here, what I'm telling R is that, hey R, I want the X values for this histogram to be grade. So I'm creating a histogram for grade. And I do that by using the AES, open parenthesis, X equals grade, close parenthesis, and another close parenthesis. Then I'm here for ggplot function. The plus sign is used to indicate additional arguments. So I'm not only telling R to work on chapter 4, specifically grade, But I'm also telling R that I want a histogram, and that is called in by the geom underscore histogram function. So I want the histogram with a bin width of 1. So the bin refers to the bars that you see in the histogram. I want the color of the bins to be white, and I want the bins to be filled in with dark olive green color. So that's how I want the histogram to look like. Um, Another iterations for this, if I can manipulate not only the bin width, but I can also manipulate the number of bins that I want to be shown. So if I want 20 bins or 5 bins, meaning 5 bars, 20 bars, I can also use that using the bins function. Bins equals the number of bins that I want to. But I don't want to do it now. I'll probably do it in another video. In this particular task, I want to use the bin width, and I want it to be 1. I want the color to be white, and I want to be filled in with dark olive green. Aside from that, I want to create uh, a curve. I want to superimpose a curve on the histogram. Now, this particular command, which is called the geom underscore density, uh, does some form of calculation on the back end, approximating the height and the width of the curve to be superimposed based on the value of y. So in I haven't explored really on the geom density function yet, but in my experience, usually if I set the bin width to be 1, then setting the geom density y value as 1 is usually helpful, or it's usually good to have the bin width value the same as the y value here in the geom density function. Another thing here that I'm telling R is that I want the curve to be color black, and I want to adjust it to 2. So this is something to do with the smoothness of the curve. Um, and we'll probably will play around a bit on this once we run the command. Aside from that, I want R to put a label on the y-axis. So the labs function is actually telling R to uh, label the uh, particular axis that you want in. So here I want to use frequency as the label for my y. And uh, later on, we'll probably play around. I forgot if we can actually make use of the labs function here to create the main title. So if I run this particular function, and you see here, there are no errors, so it means that it's there. And you look at the plots tab here, you can see that R created a histogram for us with bandwidth of 1. It has a normal curve, or a curve superimposed in it, showing how far close it is to a normal distribution, and it is colored dark olive green. And I want then the y-axis is labeled as frequency. Now I want to try if using the main function will give us a title. So if you look at the labs function here, I want y to be labeled as frequency, and I want my main title to be labeled as histogram. So let's see if this will work. If it doesn't work, then probably we'll try it next time. Didn't give us any result. So it was not giving me the title that I'm using. So probably I'm doing something wrong. But at least we were able to do, what do you call it? The label for the Y frequency. Let's try to check uh, the labs, what it actually does. So the labs here, it says X label, Y label, the GG title, caption. So it should be title. So let's try title and see if it will work the way we want it to work. See, so the title function actually brings forth the main title or gives us the main title in the plot. So usually that's what I do if I get lost in what argument. I just make use of uh, the help feature of R. So I can just do that by typing in the question mark and typing in the specific commands that I need. So I don't know what arguments are possible for labs. So I do question mark labs, run it, and in the help, it shows me a certain instructions. So the usage is here, and it tells me that the title argument is what is to be used if you want to have the text for the title. So that's basically what I did. I just followed that instruction, put a comma, use the title argument equals histogram and quotation marks, then it gives us title. So I can type in histogram for grades if I want. And if I run this one, it will allow me to change the title. So the ggplot function actually is very flexible, and it allows us to play around with different arguments to uh, um, customize the histograms that we are creating. So let's run some more histograms using the same function. So what I do, since I'm basically a lazy person. So what I do, and it's actually I think smarter also to do it in R, is just to copy the script that I want to use, the syntax that I want to use, and just replace the variables that I need to work on. So I copy it, just replace the X variable with the variable that I want to work with, just replace the colors, the fill, and the labels, and it will take a lot of time away from having to type it actually. So it helps a lot to have that. And this is particularly where the role of the script file is helpful for me, because I can just uh, type in the commands and reuse that same command in a different data set in the future. I just go back to that script, copy the syntax, paste it on the new script, and just replace it with the variables, the data frames that I'm working on. So just a few more ggplot here that I'm running. So I've already done it. And I know that it is working because if I go to the plots part, I can see all of these showing here, the plots that I'm making here in the script, in the console, or appearing here. So I think we'll end this part of the video by learning how to export the plots. So there is another way to export all the plots all together, and I think we'll discuss that in a future video, specifically if including all of the functions that we used here, and that. But for the meantime, we're going to export the video individually, either as an image or as a PDF. So it's just basically using the point and click features. If I go to this particular plot, I want the par and histogram. I want to export it. So I just click on export, click on save as image if you want to save an image. Then I want, if I have options here, if I want the image to be PNG, JPEG, TIFF, or whatever format you want. So I want it to be in a PNG file, probably a JPEG file. Then the directory is where your working directory is. This is where you have saved, or we have told R to save all your files, class exercises. Uh, you have a file name. So if I want, the default is rplot, but I want rplot parent, I can change the file name of this particular image. Then I can just click save. So if I go to my files, you can see here that it's already saved in the uh, working directory, the rplat parent. So I can also say, for example, go to another file and want to save it as a PDF. So I'll click export, save as PDF. So the PDF size, I want it to be saved in letter, US letter size, portrait or landscape, depends on your preference. The same way, you have the directory, you can change the file name and save it. And when you go to files, you can see here that the PDF format of the plot is already saved. I can just click it, and when I open the PDF file using whatever PDF reader you're using, and it should be showing the plot that you have created. So we'll stop here, and in succeeding videos, we'll talk more specifically about correlations and creating scatter plots using ggplot. This is bringing us closer to the linear regression, the simple bivariate regression that we're going to run using this data set that we are using.